Okay, that was a very smart thing. If you got 30 seconds left, don't say anything stupid. Not me, though. I would use the time. I would use the time. All right. Now for the people that are still following us via the live stream, hello, we're still live, keeping it going. It's going wonderful, great. Now next, we have one more pilot project presentation. And for this one, I have from STMicroelectronics, and about energy, I have Gavin to join me on stage. Ladies and gentlemen, let's receive him on stage. How are you doing, sir? Everything good? Everything good? All right.
Thank you very much, and it's a pleasure to be on the stage. My name is Gavin White. I'm one of the co-founders and CEO of About Energy.
Good evening. My name is Alessandro Troisi. I'm Senior Application Engineer. I'm pleased to stay here as a representative of STMicroelectronics to present the solution we implemented together with About Energy. Well, each of us know that to build a real system, to do a proof of concept, we start with a real element. We need the software, we need the hardware, and why not? We need also an ecosystem that can help, especially the new company, to build a new solution. That's why About Energy started some months ago with our kit, our BMS kit, to verify the state of charge accuracy for different cells, and using their battery models. This is our BMS kit. It's characterized by BMS board, ISO SPI board, and a battery holder. All included in Autodev kit, an ecosystem that we developed to improve, to speed up the prototyping. I leave the stage to Gavin.
Cool. Thank you very much, Alessandro. So a little introduction to About Energy. We're a spin-out company based from the UK from two world-leading universities, including Imperial College London, where I did my PhD. And the core IP of our company is our ability to measure the properties of batteries really accurately. And we can do that for a range, and we already do for a range of proprietary and commercial technologies, for all the formats of cells, for a range of chemistries, including sodium-ion, LFP, solid state, so the next generation technologies, as well as we have core IP in the 4 categories of battery models, so electrochemical, thermal, electrical, and degradation. And what that offers is a full solution to our customers, such as Porsche, who we presented with last summer. And there's many challenges when it comes to BMS development. Typically, BMS development is extremely expensive. It requires very specialist engineers writing often like C code, so very low-level software language. And this ends up being really expensive. And at the moment, there's a real crunch in the battery industry. There's a real lack of skills that are required to do this. And the problem is that the industry is extremely fast-paced. So we all think of the battery industry as being huge today, but the reality is that the growth is just beginning. And there's 3 key components of a battery BMS. So you've got the hardware, which is the physical silicon chip, which STMicro make. You've got the algorithms that predict the state of charge, the state of health, etc. And inside the algorithm is embedded a model. And that's where we come in, where we provide the battery model and the data that goes on that model for the chip. So working with STMicro, we've been able to deliver a full solution here, where STMicro deliver the hardware and the algorithms using an off-the-shelf algorithm available in MATLAB, and we provide the data that can plug straight into that. And this takes what BMS development takes months with specialists down to literally just minutes through a drag-and-drop system. So here's some results of that BMS in action. So what you're seeing here in the black line is the experiment, so the real-world experiment, and the green line is the prediction for the model. And on purpose, we initially offset the SoC for the model to see if the model can self-correct and find what the real SoC is. So SoC being the state of charge. And you can see that very quickly for 2 different chemistries here, that this off-the-shelf solution is able to very quickly converge on the actual state of charge of the battery. And it does this at extremely low error, despite the very complex drive cycle. And to test this out, we swapped the chemistries and kept the old experimental data. And what you're seeing here is if you have the wrong battery data, i.e. you don't have the correct data from About Energy, the model will fail to converge on the actual SoC and you end up with this huge error. So that's like a 20% error in state of charge, which is like unacceptable for, say, an automotive car in application. So by working together, we've been able to deliver a full solution using STMicro's hardware and their platform, using an off-the-shelf MATLAB state of charge estimator and about energy data. We've taken this process that is extremely complex and difficult and been able to merge that into a single solution. So it's great to be able to present that with Alessandra, and I just want to say thank you very much to the whole STMicro team and the About Energy team that put this together. Thank you.
Thank you.
All right. Thank you so much for the presentation and for also sharing insights about this amazing project, and actually for your impact on revolutionizing e-mobility by facilitating low cost and in-house development of battery management systems. We would like to hand over to both of you our Plug and Play Open Innovation Award 2024. Congratulations.
Thank you.
So one.
Thank you.
And the other one. Perfect. And one picture.
Thank you.
All right. Thank you so much, guys.
Great. Thank you.
Big round of applause.
Thank you.